I am going to be doing an anatomy of a Redis command. My name is Madeline Olson. I am a software engineer here at AWS. You can see our awesome spheres here. If anyone hasn't had a chance to visit them, they're really cool. I would also plug Dimitri's meetup. It's a great place. I did a talk there once with like 3 people in the audience, so we could always use more people coming.
You did more than one talk.
I have done more than one talk. I think only 2, but you know, I'm always there to do more, so you guys should come. All right, so what am I going to be talking about? So the whole gist of this talk is kind of to give some intuition about what's going on in the Redis server when you execute a command. So we're not going to be diving too much into code, so the agenda will roughly be, I'll kind of give you an overview of how the internal Redis structure is, like how Redis processes commands, how it like works underneath the hood. There's not going to be a lot of code. Hopefully, no one's too shy about that. How many people have actually read the Redis source code before? OK, that's quite a few. How many people have submitted a pull request to Redis before? Even fewer. So I have submitted about 25, 26 at this point. So hopefully, maybe you guys would feel a little more confident looking at the Redis code base after this. It's really readable code. So once we've given that sort of overview, I'm basically going to show you a stack trace of a Redis command, what commands are being executed, and then we're going to dive into each of those sequentially to kind of dive into what's happening at each of those steps. We're not going to be covering actually a lot of the Redis source code. Most of the source code is just going to be in 2 files. Almost everything else as Redis is dealing with more complex stuff. We're just going to give a very simple case. And then at the very end, we're going to talk some implications and takeaways and kind of talk about since the stack trace is kind of going to be an idealized case, I'm going to try to talk into some of the more nuanced cases and some of the features coming in Redis 6 and how they change things a little bit. So just to go over, the Redis fundamental that you need to know is that it's built around a single-threaded event loop. You heard earlier that there are other threads in Redis, but it's kind of built around this single event loop. And so this event loop basically responds to read and write events to file descriptors. So for those of you that aren't CS fundamentalists, a file descriptor is a way to represent like input and output. So it's a way for the kernel to tell Redis this input-output stream has data to read to or read from. So that's a way of thinking of if your client is sending data to Redis, the kernel will notify Redis that something is ready to be read. Right? And so this is used to accept clients, read queries, write data out to replication streams. So this is kind of like the core loop of Redis. So it calls this, in Linux it's called epoll, in BSD it's kq. So it calls this epoll function. It has a after sleep, because it's just woken up, callback. Then we'll go and process all these events. Then it calls a before sleep, and then it goes to sleep. So this is the core event loop within Redis. And the only other interesting point here is it also can handle some periodic jobs, which is how things does like replication and has a server cron for disconnecting old clients. So that is kind of like the core thing of Redis. And you can kind of see how everything gets handled here. OK, so let's dive into the stack trace. So this is a stack trace of the Redis command called debug, specifically the debug segfault command, because when Redis crashes, it prints out the stack trace. So you can generate this yourself on different versions to see how it's different. So you can see, starting at the very bottom, we have the main function, which is the start of all C functions. The AE main, which is that starting of the event loop we talked about. AE process events is that second step after the before. After the after sleep. And now we're getting into the new stuff. So you can see that there's basically 5-ish main functions. There's process input buffer, process call, and then the actual command itself, plus the process events. So we're pretty much going to be covering those. If you want to follow along, you can open up the Redis source code. This is all going to be in server.c and networking.c. Networking.c will handle the networking, obviously, and the server will handle everything else. This stack trace is not necessarily complete. The compiler will actually optimize away some of the sub-function calls, but this is most of the function calls. So now we're going to go through the stack trace and just think about a very happy case. So the command we're going to be looking at is set foobar. So we're going to set command. It's going to set the key foo, set the value to bar. So the first step is going to be the network hop, where a client is executing this command. Looks maybe Python-ish style or something, where we're sending this command off, and it's going to go over the network, go through the TCP stack, right to a remote server. This same example still works if you're using something like, if you're on the same host and you're connecting over a Unix socket. The same thing sort of applies. So the kernel is going to read that data in to an input buffer on the kernel. Next, the epoll loop we talked about earlier is going to notify Redis that there's data to be read. Not sure why that disappeared. And so then this is going to fire. So then we're going to get to the first interesting call within Redis, which is going to be read query from client. So the responsibility of this function is to just read stuff from the kernel and read it into Redis. So Redis has multiple different protocols if you aren't terribly familiar. The one that we're showing here is the inline protocol, which is just space delimited values. There's also the multi-bulk and the REST v3 protocol that were touched on a little bit in the introduction. So at this point, it's just reading in raw data into Redis. So every client within Redis has its own structure, which is called client. And it has something called the client input buffer. So this is just a buffer that accumulates incoming commands until it has something to execute. So Redis will attempt to read a fixed amount of size every time, and it will read in as many commands as it possibly can without really worrying too much about what's there. The only validation that we're doing at this point is to make sure we're not reading in too much data. So there's a client input buffer limit, which is the protocol max limit, which is a configurable value that defaults to 512 megabytes. So that's the largest size that Redis can read in for a single command. So at this point, we just have a raw string within Redis. So next, we're going to hit the process input buffer type commands. So the responsibility of process input buffer is to convert this arbitrary string into an actual command. So what it'll do is it will go and check through this command that's reading in and looking for a /n at the end. So that's the new line character, which is basically delimiting the end of a Redis command. So all the three protocols have that in common. So once it sees that, it will then go and process each of these different types of protocols and generate basically a list of strings. So in this case, it will successfully break it up into set, foo, and bar, and that will be stored on the client. Internally within Redis, it basically thinks of everything as a client with a set of arguments. And so when a command handler is actually called, it will basically expect this sort of format. So at the end of process input buffer, we will have this set of arguments, and we'll pass it into the next function, which is going to be process command. So process command is going to be executed once for every command within Redis. So at this point, it's going to go and check what is basically the first argument. In this case, it's going to be set, and it's going to look it up from a command table. So internally within Redis, there's something called the Redis command table, which is just basically a giant list of all the commands that are supported. You can see in server.c at the top of the file, it's this giant, 1,000-line block of a struct. And it basically defines what all the commands do. So every command has a set of flags, which determines when it can be executed. Is it admin? Is it write? Is it a read-only command? Can it be executed within a Lua script? So all of that gets defined there. And then at that point, process command will basically validate, can I execute this command at this point? It won't actually execute the command yet. It'll just validate we can. So let's dive a little bit more into what that validation is. So as I said, it looks up the command. So it does a lot of validation at this point. So as I mentioned, there's flags associated with commands. So one of those flags is this a write command? If that flag is set, it will check, am I executing this on a master or a replica? If it's on a replica, it'll reject the command at this time. And if it is a master, it'll check what's the memory policy? Am I allowed to write? In Redis 6, it will now also do all of the ACL validation. Can we execute this command? It does a lot of special validation for cluster mode. Check, is this the right node? Is this the right node? And am I a read-only client executing a read command? And this will also then submit the redirect notice if it's actually sending it to the wrong command. And so once all that validation passes, it then goes into some the special handling. So there's a lot of special handling like the quit command. The quit command is just basically if the string is equal to quit, immediately quit out. which is why the quit command behaves a little weirdly. You can't multi-exec a quit, because it will just immediately bail out, unlike everything else, which will get queued, which is a little interesting. Speaking of multi-exec, the multi command will put the client in a very special state, which is the multi-state, which will basically return all of these queues. So when you're in a multi-state, the command will get validated, but it won't be executed. It'll basically be queued up, and at the very end, Redis will execute all of your commands together. So in this case, all of the validation happens up front, and all the execution happens later, which means you can do something like multi-execute like 10 gigabytes of data into Redis. And so every single time you do the write, the validation will pass. If like you have the max memory policies, like max memory set to a gigabyte, every single one of those commands will succeed because there's no data in Redis yet. But when the multi-execute happens, it only validates. Since it's no longer revalidating the commands, all the data will go through. So then the last thing that happens here is the module stuff happens. There's a couple of special like before handlers, after handlers. So worth looking for the new module v2, which adds more stuff here. OK, that was a lot. So now we're getting to the last call, which is called call. And its responsibility is, I am going to execute this command. What do I need to do in addition to that? So call always succeeds and always executes the call you're asking it to call. So it actually calls the command handler. As we mentioned before, there's a giant table of all the commands. It goes and pulls the handler out, then executes it. It also will capture all of the metrics that you see when you do like slow log. If you do Redis info call stats, you see a bunch of stats of how much time are the commands taking. That's just this amount of time, just the actual call, and not all of this other validation around it. This is also where all the propagation handles to replication. Since we assume that these calls will always happen, we need to make sure at this point, if validation fails, that's why you won't see stuff in monitor. You only see when the validation passes. So that's why you might see some differentiation between like, if you pass in a command with the wrong number of arguments, that gets handled in process commands. But if you send a like set command to a string type, it will throw a validation error saying you passed in the wrong type, and that will show up in monitor, but the one with the wrong number of arguments won't. That's because of where this validation is happening. Validation that happens within the command itself is logged, but ones that happen, like fundamental errors, are not logged. So that's interesting to note. The last thing that call does that's worth pointing out is call is also what gets called recursively. So if you were basically running a Lua script, you're allowed to call other Redis commands. So it does not go back up to process command. It calls directly this call function, which means that Lua reduplicates all of the validation and actually does a subset of it. So it doesn't implement the like memory check, because Lua is supposed to be atomic, but it re-implements some of the stuff like, am I on the right node for cluster mode commands, and am I allowed to execute this command from a Redis ACL perspective? So yeah, then the other ways that recursive calls happen are with multi-exec and with modules. And those two also re-implement a lot of the same logic. It's also why you'll sometimes see some differentiation error message. If you send a command you're not allowed to execute, you'll see a different message if you send it in Lua as opposed to a regular command, because they are two separate strings that are returning back to the user. OK, then the last thing we are executing is the command handler. So this is what we got from the command table. And you can see a good example of this in the README for Redis. There's a little section at the bottom called Anatomy of a Redis command, which I didn't notice there was a name conflict until yesterday. A little late to change the name. But basically, its responsibility is it takes a client in and basically just dumps output on the client output buffer. So just like all clients have an input buffer, they also have an output buffer. So this output buffer fills up, and then it gets written out. So at this point, it will go back up the Stacktrace. We've now hit the bottom. And if you sent multiple commands at the same time, something like batching or pipelining, it might go and then process another command that goes through the same process and dump more output onto the output buffer. All right, great. So what happens next? Next, we wait. As we mentioned, there's like that process events. We don't immediately write back to the kernel. We wait for Redis to go process other commands. And so why does Redis do this? It's trying to optimize the number of system calls it's making. Doing a write is actually really slow, and is one of the motivations for why the IO threads is getting implemented in Redis 6. So Redis tries to optimize how often it's doing these system calls. In addition, it might be doing other things like timer events. So it doesn't actually go and write data out until that before sleep function we talked about earlier in the event loop. So once that happens, a function gets called handle clients with pending writes, which is not something we saw in the Stacktrace, because it happened at a different point. And so this basically just happens at the end of the event loop. Once all the clients are processed, Redis loops through all of the clients it knows have pending output, and then finally writes them to the client, the kernel output buffers. And then at that point, the kernel will do its best to get the data off to your client, and now you've received your OK. So if you're kind of thinking about the time-wise of this, the two ends, the network hops, are going to be the biggest delays. If you're writing across the continent, it'll be 100 milliseconds, and within a data center, maybe half a millisecond. The read and the writes from kernels are only going to be between like 1 and 5 microseconds. And then the actual command validation and execution itself is going to be really fast. It's going to be on the order of maybe a microsecond. So you can kind of see the wide differentiation in timing. So that's kind of like the happy case. The case I wanted to talk about in a little more detail is, didn't Redis 6.0 add multithreading? And how does that work with this picture? Because this kind of assumes a single-threaded model. So even though Redis 6.0 is multi-threaded, it still follows the same single-threaded model. So the bottleneck, if you actually do profiling, is that network I/O, the system calls, the reads and the writes. So what Redis tries to do in Redis 6.0 is it tries to fan out those reads and writes. So if you can think about in the before and the after hooks within the event loop, it tries to fan out those reads and to fan out the writes. So how does it do that? So when it calls that epoll event, it will go and find all of the clients it needs to read to. It'll collect them all, and then it will start threads to go and read that data in. Then it will collect them all back together, and then go and process the command sequentially, so just like it would normally. And then at the very end, it's going to go see all the clients it has to write out to and fan them out again. So it's still very much a single-threaded model. It's just able to better utilize extra cores if you have them to be a little bit more performant. So just to kind of give another example of that, you can see that if you do a stack trace while using the IO threads enabled, you'll see that there's no reading from the query buffer because that's already happened previously. So it'll read from the query buffer ahead of time, and then it'll execute they'll do the processing. So to come to the takeaways, just to go over the happy path of a Redis command, it will do the read, the process, and the execution of every command on a client it can within a given read. It'll then go through, it'll also then write all the responses after processing all the clients. That's kind of like the key takeaway there. Some things you can kind of infer from that. It's why pipelining and batching can help you be more performant. Since the system calls are the bottleneck, it can help you be a little bit more performant if you're sending multiple commands at the same time, and they'll be executed together. It's also why, if you're doing pipelining, stuff can seem atomic. Because if you send 2 commands, they're most likely going to be read in at the same time and then executed together. But the only way to really get that is with multi-exec or Lua. And then the other interesting thing is kind of the way multi-exec and Lua happens. For the most time, validation only happens once in that process command that we talked about. And then that's why you'll see some differentiation when recursive calls are happening. You'll see some different validation because they're actually re-implementing it. And the last thing, Redis 6.0, even though it says it's multi-threaded, it actually still has the same single-threaded model. So a lot of the simplicity within Redis is still there. So that's all I had. Thank you very much. Hope you guys learned something new about Redis. I guess we have a couple minutes if anyone has questions. Anyone? Oh, sure. What's up? Sorry.
Hi. So regarding the point where multi-exec blocks essentially only replicate some of the validations, is there then an inherent advantage to just run everything as a single command, for each thing? Is there kind of an advantage to that?
So the multi-exec guarantees everything gets executed atomically. So if you want these 5 commands to be executed together, that's why you use a multi-exec. Like, make sense?
Sure.
Okay.
New to Redis, so.
Okay, yeah, that's fine.
Anybody else? Oh, there's a hand. Oh, there we go.
Oh, hi.
All right. Anybody remember Phil Donahue?
So I'm just curious. It seems that Redis is CPU bound and not IO bound, basically, because most of the stuff it does is in memory. So what are the advantages of the multithreading that you just showed in Redis 6? What I want to ask is how much improvement can you actually see from that?
Yeah, so that's a good question. I'm trying to think if you can go. I think Anterior's post had a blog post about the performance benefit. You can see like close to like 2x benefit if you're using like 32 threads or something. It's not very more efficient. The most efficient thing would be to like run Redis cluster with 2 nodes and then like to completely shard out so you can use like 2 processes on the same host. That'd be the most like efficient thing. But yeah, I think you can get like close to 2x. If you do like profiling depending on like the hardware you're using and depending on your kernel, you can see about 70% of the total time in Redis is spent doing the system calls for read writes and epolls. So you can basically get all of that back and parallelize it all out. So then you're that 30% actual command execution time is the bottleneck. Another thing you can look at is if you just like use Redis with pipelining, if you're familiar, you can send like 100 commands at once, and that kind of gives like the upper bound of how performant Redis can be, which is like, I mean, it depends on your hardware. So, you can see big differentiation. There were some numbers that Yiftas showed earlier. Yeah, make sense? Cool.
Okay.
Got 3.5 minutes.
We have a couple minutes.
Can keep
Okay.
talking.
All right.
My voice.
Is there a question over here?
Great talk, by the way. Thanks. I have a question with multi-exec and Lua. Is there a way to find out that you won't have enough memory once it actually executes?
Like before it actually executes?
Yeah.
Not really. With Lua, I don't think you can execute like info while Lua is running. I mean, you can do like checks within Lua. Multi-exec, everything's going to execute, so you really don't know what's going to happen. If you write 10 gigabytes, it's going to generate that 10 gigabytes of data. With Lua, you might be able to check the current memory. I don't know if you can run info within a Lua command. You definitely can't run config. So there's probably not a good way. So make sure you're not being too dangerous. It's the best recommendation I can give.
Okay, here we go.
Can you comment on the difference or the same approach on elastic caches and hence I/O versus Redis 6 multi-threaded I/O?
It's conceptually similar in that we're offloading I/O onto other threads. So it's kind of doing the same thing. It's conceptually similar.
In terms of performance,
so we have a blog post. If you look at the numbers, I believe ours is slightly more performant, but we have a blog post showing specific numbers with benchmarks. It's really easy to not give an apples-to-apples comparison with Redis because it's so performant. If you run a slightly different set of hardware, you'll get different numbers.
Okay. All right. Great. Well, thank you very much, Madeline.
Mm-hmm.